Suppose we want to calculate the definite integral 0 to 1 of cosine of pi t dt. First of all, let us calculate this integral. We're going to apply the method of u-sub. Let u to be pi times t. So du is equal to pi dt. So in turns, dt can be written as du over pi. Well, okay, this integral becomes the integral of cosine of u, and dt is now du divided by pi. This can be written as 1 over pi integral of cosine u du that you already know how to deal with. This is 1 over pi sine of u, and please note that you have u. Your u needs to be substituted back here, and you can write it in terms of t as well. If you decide to leave it as u, then you have to change the boundary of the integral. This can be written as 1 over pi sine of pi t, and now t is bounded between 0 and 1. So we're going to apply the fundamental theorem of calculus, get 1 over pi sine of pi minus sine of 0. So in order to calculate this integral, you either memorize the unit circle, or you know that the sine of pi is 0. Sine of 0 is also 0. So the output is equal to 1 over pi times 0 or 0. This definite integral is equal to 0. So again, if you decide to keep this as u, you need to change the boundary. If you write it as 1 over pi integral of cosine u du, what are the lower bound? What is the upper bound? Remember that when t is equal to 0, since u is equal to pi t, u becomes 0 as well. When t is equal to 1, since u is pi times t, u becomes pi. So the lower bound is still 0, but the upper bound is now pi. And you can keep this as u and work with u instead of t. So this becomes 1 over pi sine u, and the bounds are 0 to pi, which in turns is equal to 1 over pi sine of pi minus sine of 0. But again, it doesn't change the fact that this guy is 0, this guy is 0, and the output is 0 as well. So you either resubstitute and write everything in terms of t, or you can leave it with u, but make sure to change the boundaries as well. Another substitution is calculating the integral of sine of 40 while t is ranging between 0 and pi over 4 dt. So you can use substitution, u to be 40, and then du is 4 dt. So dt can be written as du divided by 4. So this integral in turns can be written as the integral of sine of u, and dt is du divided by 4, which is equal to 1/4 integral sine u du, which is equal to -1/4 cosine u. And again, if you want to keep it in t, you need to substitute back into the final answer, -1/4 cosine of 4t, and the boundaries for t are 0 and pi over 4. So this in turns can be written as -1/4 cosine of 4 times pi over 4 minus cosine of 4 times 0. This is equal to -1/4 cosine of pi minus cosine of 0, which is equal to -1/4. Cosine of pi is -1. Cosine of 0 is equal to 1, so you get -1. So you have negative times negative, 2/4 or a half. If you decide to keep it as a u, you need to change the boundaries. So let me write down or here for you. So if you decide to write it as the integral of sine u du over 4 or 1/4 integral sine u du, please pay attention here. Since t is equal to 0 and u is 40, u becomes 0. And since t is equal to pi over 4 and u is equal to 40, u becomes pi. So the lower bound is 0 and the upper bound is pi. So this integral can be written as 1/4, and the integral of sine of u is negative cosine u, and the lower bound is 0 and the upper bound is pi. So what do we see? We see we have -1/4 times cosine of pi, which is -1, minus cosine of 0, which is 1. So you get 2/4 or a half back. The final answers are the same. But some people prefer to write this in t, some other prefer to convert everything into u, and the boundary must be changed as well.